Okay. It will not help. It will not help the quality of the stream if I choke to death on dry bread. Okay. So the goal now is going to be to get something reasonable to come out the speaker in a non-threaded way, and then we'll make all the threaded stuff work. Wow, I swallowed a piece again. Now, what I remember from yesterday is that we had some variable in the cache decoder called do not queue, which maybe is duplicate, because we had this do not queue thing happening, and then we had that threaded variable in the other file. So both of those are set to a consistent thing that should cause us to always force recompute a page. So really now, I think my next move is just to start doing printf debugging, which of course you know I really love, not. And I'm just going to see what's going on. I wish I had a real debugger, but I don't yet. So it's printf time. Printf time. So go to the program. And when we load the thing, it should be in sound.sounddata.buffer. So this could be null, so let's do that. And then we'll print so that should give us lots of information, hopefully. Oh, I don't want to run, I want to compile. Ooh. So it's struct compressed name lullaby set. 0 samples yet, which is to be expected because we haven't started decoding it. Right? And then the buffer, this is correct. We're just dumping a string because this is a string, right? And the generic print function doesn't look and see binary data and say, oh, we better not print the whole thing. It just dumps the whole damn string. Or maybe I limit it to the first large number of characters. I don't know. But anyway, this is actually the valid data of the OGG file. So it's loading correctly. That was question number 1. So we don't have to worry about that. We are loading the file correctly. Oh, wait. However, no, we're not totally, because I believe the OGG file init is supposed to figure out this num samples right away. So we didn't do that. Maybe we just forgot to do it. So if extension is OGG, we read the file, we make a new sound data. Okay. In the mixer, Oh, you know what? Yeah. So that doesn't happen until we get into the mixer, right? The mixer says if it's odd compressed, oh, we assert false in the mixer if it's odd compressed. So we never get there. Why do we never get there? I thought we printed that in our previous thing. Oh. I don't know. I'm just guessing that that's what these variables are called. Nope. Well, file. It is called sound data. All right. Well, the type of it is odd compressed. It's good that we print enums out using their names. That's always nice. Okay, so why isn't that making its way into the mixer? This is a mystery. It's a mixer mystery. Probably something is happening. So let's just look here. We're going to spam. This is going to happen once per frame. I'm going to say some number and sound bam, comma, index and sound name. Is that what it's called? Yeah. See what happens there. That should tell us if this is in our main loop. Yeah, see, so sound lullaby set is there. That's good. It's making it into the mixer. Okay, well, it's trying to start the stream for it every frame, which means it's not succeeding. So that's a bummer. It's not that much of a bummer, though, because that means we're honing in on our bug. Okay. So create stream is rejecting this for some reason. That's fine. In theory, that assert should be okay. Okay. So its data is not null. Start spanning some prints in all our cases. So we get reject. It's not reject 2, it's reject 1. So data.samples. Oh, yes, we didn't set samples. I really think that should be data.buffer. So this is just, you know, for the old code, maybe I always pointed samples and buffer at the same data. But it's not really valid samples if it's a compressed file. Let me see if I do that a lot. No, there's no reference to dot samples. And let's go to mixer async. Okay, that's only, yeah, okay, so it's fine if I change that. It's not like some big convention. Okay, well now we've got an assert going off. And again, I have no idea which one, which is a little bit sad. I really should invest some time into doing a stack trace for the compiled code. It probably wouldn't be very hard because there's lots of, in fact, I'm pretty sure Sean on his webpage linked to a one-file stack trace utility, I think. But I haven't done that, and I don't want a rat hole doing it now. So now, more printfs, yay. Oh, you know what it is? It's probably that this, I said there's an assert here, right? So let's make sure it's that one so that we don't have to hunt around for it. Yes, asserting false. All right, so we don't want that anymore anyway. I want to create the OGG decoder. When we create the OGG decoder, that should set the sampling rate and all that. So I'm going to print that. How about channels, samples, all right. Let's print that. Okay, got 2 channels but 0 samples, which is not good. Not good at all. Not good. Let's go look at create OGG decoder. No, I never saw the language clay. All right. Create. What am I looking for? Create OGG decoder. Yes. Okay. Yeah, maybe if I get everything else working, I'll clean this up today. This is going to bite me so hard. Oh my God, I'm going to forget about it. Let me write it down on a piece of paper. It's that important because if I just leave that hack in there and forget about it, I'll be a very sad person at some point. Okay. Well, okay, well, those both worked. We're just not stuffing it into the sound data. right. That's all fine. Let's get rid of these. So our create.og decoder is good. Why don't I, at this point, I'll run devenv on this, because that'll tell us where we're asserting now. Wait, why didn't that have to say .exe? All right. So this should tell us where we're asserting. Except no, because assert doesn't like int5 exit ones. I'm going to change assert to crash. That's what I'm going to do. So I'm going to go into the compiler. No. Oh, wait. Assert is actually defined here. Oh, but it's panic, right? Okay, so panic, instead of exit 1, I'm just going to panic, and I'm going to say void star x equals null. Int star x equals null. Star x equals 0, right? That's a pretty poor way to int5 or whatever, but we're dereferencing a null pointer intentionally. So let's recompile the compiler. I can use the line macro, sure, but that's not going to help very much. I mean, I need to get it to give me something that you could even map to a line macro, right? I mean, just think about how specifically you would use that information yet. I actually do put line. Oh, you mean, can I not use line macro in the language? This is an assert in my language. It's not in C++, and I don't have macros yet. We might have them eventually, but they don't exist yet. So assert is not a macro, so it doesn't expand into anything where you could like insert anything. So that's a whole issue. All right, so we've rebuilt. So now we should be able to rerun that here. And our panic should actually panic. Okay, good. Do stream entity pass. And so here I have sort of line numbers emitted in the comments. So I'm in mixer line 1345. That's much better than hunting for printfs. Oh, it's just another assert false that I inserted back when I said we're not implementing the decoder yet. So many windows. I'm just juggling a lot of windows. Hey, we're not crashing. I don't hear music, however. All right, I have to play. No, you know what? I'll play for real when we get the music going, because that'll be my reward. Right. Play for real when we get the music compressed going. Okay, well, we know that we got at least to this point, right? see what happens. That should spew every frame. Okay, well, this number should be advancing every frame. That's the play cursor on this sound, right? So the sound's not playing yet. So we get to investigate why it's not playing. Print, stream. Do we put a name on the stream? I don't remember. No, but we have sound data. All right. Now I suspect that we're stuck waiting for pages the whole time. That's what I think. Because when you start a compressed sound, you don't want to start actually playing the sound and then decompressing takes a long time, and then you run out, like the samples you're trying to play catch up to what you're decompressing, because then you have nothing to play. So generally, you start your sound decompressing for a little bit, and then when enough pages are decompressed, you actually start playing it. Now, I suspect that that's what's broken. For some reason, we're not putting the pages or something. Nope. We never fired that print at all. Fetched is this much. Needed is this much. Stream.fetched. Samples needed to start playing. We're not even printing. Are we just killing the stream? What? Now I'm confused. No. It's still there, every frame. I thought I'd check that if statement, but let's see. No. What? Oh wait, I guess it's never in the waiting for initial decoder pages state. Okay. I guess that could be fine, right, because, well, maybe we only set that if we're threaded. Right, we only set that if do not queue. Okay. So it makes sense. This all makes sense that we wouldn't have been in there. Okay, so update from async thread. Let's check that. So this is a thing. This can run from the main thread or from worker thread. Because if the main thread is taking a long time to render a frame, you don't want your sound to stop, right? You want it to keep going. You generally have a good mixer running from a thread that's high priority. So the way this works is we figure out how many output samples we need to do every frame, and then we call fill sample buffer, and that's going to iterate over all these sound streams, right? So that calls accumulate stream. And let's make sure we're getting here. I'm going to be so happy when I have better debugging facilities. I can't even tell you. Okay, we're getting there for a lullaby set. For some reason, well, let's put that down here. We already said we never go into that wait state, but let's make sure. Whoops. Yep. Okay. So basically, I'm just going to check all the reasons you might bail out of this function. Yeah, range is 0. Oh, because we're not setting these variables, I guess. So even for non-repeating sounds, we use this repeat start and repeat end position because you know, then you just use the same so you can set a repeat point in the middle of your sound, for example, if you want it to loop for a while and then play the tail after it's done looping. But if it's not looping, you just want that to be the end of the sound. So you can just set that to the end of the sound in the case when it's not looping, right? Anyway, so that is probably getting computed back here. And we're probably just not setting the sample variable that we need to set, sample count. We set at least one of them, but there's probably more than one. Repeat and position. Get set in create stream. So okay, I am confused because I ported this code directly over to C++, and in C++ it appears to work. But it looks to me like I call create stream, which sets those variables, way before we entertain the possibility of making a decoder for it. So I'm going to have to go look in the C++ version for a second because this is weirding me out. So create stream in C++ is doing the same thing. It's setting repeat start position, repeat end position. Let's see if anyone else sets those. No. Okay, that's it. Create stream is being called here at the top of the loop, just like usual. Oh wait, is it in a different function that we... Oh, it's in create stream that we make the decoder. I am confused because we make the decoder down here and we use these variables up here, but this code runs in the witness. Like, what the hell is going on? Does the cache log decoder stuff those variables? No. This is weird. Oh, you know what? Maybe it only works because we're running threaded. I don't know. I'm writing myself a note on a piece of paper. Fix this, or at least understand why it even works. Because it looks to me like it just shouldn't work. Sometimes it's amazing, like you have software that you run every day and then you're like, why does this work at all? So we should do that stuff way up here. Well, how do we, what argument do we pass? Yeah, we don't pass the, all right, we'll put this early. Instead of saying stream.sound data, we're just going to say data. Because we haven't assigned it there. Except we've already got all right. So we're going to do that. Well, let's see if that helps at all. Well, we did something different, but we just crashed for some reason. Let's see why we crashed. God, Visual Studio is so laggy. We're crashing in a print statement in create stream. All right, maybe I screwed up my, although my print statement should never crash. Oh, I don't know. Let's just not do that because we weren't really using that print statement anymore. Whoa! All right. So here's what's going to happen now. Let me comment out that accumulate. Okay, so this touching piano music has been very good to us, but really we need some commando back. So I'm going to run some gold wave. I'm going to get our commando theme. I'm going to save it as OGG. I wasn't too picky about the quality there. and to show you how dedicated I am, I'm going to delete the wave version. While that's compressing, I'm going to go to here, and instead of playing lullaby set, let's delete all this old sample code that we don't need anymore. We're going to play commando. All right, so is this in Subversion? Oh, it's 50 megabytes, by the way. Oh, I still have the game running in a debugger or something. What process would be using that? Oh, maybe Goldwave still has it open. All right. So the odd compression was pretty good. We went from 47 megs down to 3 megs. So you imagine if you have many music tracks. That's basically, whoops. That's basically what we're earning here, right? All right. So now let's get some commando going. Now we got a stew going. All right. Oh, I almost flew into the bullet. I want some spread shot. I want some spread shot. Oh, come on, guys. Yeah, all right. Oh, yeah. Oh God, I need another shield. Ah, 110, I think that's the best score I've gotten on the stream. So obviously the commando music helps. Okay, so now though, we got to get this working threaded. So that's going to involve doing some stuff, and we may not get it done tonight, sadly, but we got compressed page music working tonight, so that by itself is a pretty good victory. It wasn't too hard, mainly because I've written all that code before in another language, right? So that's the benefit. All right. Let's see. Let's implement condition variables, which again, I can go look at my C++ implementation so that I can remember what are the proper Windows system calls and all that. And when I make Linux work again for the compiler, I'll have to do Linux versions of all this, probably just do POSIX thread stuff or something. So in the witness game lib core thread dot, which actually OS win32 thread win32. All right, so condition Now, I try to do this thing in the witness engine where when we have these threaded primitives, I have a private version so that I can abstract out the operating system details, mainly for purposes of being able to cleanly include header files. We don't have header files in this new language, so I don't need to do this. So my data structure can be simpler. So like, here's my C++ definition of condition, and it's just got a private. That's the only real data, and we don't need that. We can put it all in one thing. All right. I'm just going to paste all this. This goes in thread. All right. I'm just going to start pasting the stuff into the appropriate. All right, so result is wait for single object. Event infinite, I'm going to have to define that. Reassert. Result not equal to wait failed. We don't have to do this weird Yoda condition in this language because equal is not an expression. So the compiler will yell at you if you put it in an expression context. Okay. Let me just go down here. Whoops. Delete that now. This is pretty simple. Like the Windows API has ooh, I didn't know pulse event was unreliable in Windows 7. Okay, well that's definitely a to-do. Ignacio must have written that. All right, so that's signal. Init. So all this is doing, all these functions are doing is serving as a very, very, very thin abstraction layer over the operating system calls that do the same thing. All right, so this is handle. We've already defined handle for other Windows API stuff, so that's fine. Actually, I might have to change that because I think capital false in Windows is actually assigned 32-bit, some bullshit like that. I don't know why they did that. Anyway. Very simple, very simple. You want your threaded things to be dead simple when they can be, because threading is complicated enough. I'm doing okay. How are you? Okay. I probably need to define infinite and wait failed. Let's see what happens. Yep, and pulse event. All right. Oh, you know what? I think I use those in the compiler as well. Yeah. So I can just go to the, oh, I don't use conditions though. All right. I'm going to, just to avoid witness spoilers, I'm going to turn the desktop off for a second. And I'm going to go open my witness project. You never know if it's going to open and just be on a page that tells you the secret of the game. And all I'm doing is I'm just going here and right-clicking on pulse event, and I'm going to go to definition, right? Because I could look it up on a web page somewhere, but why do that if you can get the authoritative thing? And then I'm going to look for infinite. It's right there. Go into the declaration of infinite. And then what else did I need to do? Create event. Really? I'm surprised, but okay. Okay, so we have to do this A versus WBS that happens in Windows. All right, so I've pasted those things. I'm closing my high security witness window, turning back on the desktop. So these are just the things that I pulled out of Windows. So let me just put my, I guess wait failed. Uh-oh, I didn't, let me get that off the web. All right, I'll get both of those. Okay, so let's put these constants down here. I'm only pulling in as much of the Win API as I need. So infinite, and I'm going to put I'm going to make that more qualified. I should put this in a namespace or something, but wait, fail. All right. Okay, so then we need to do these. What is bool? On a capital bool. Capital bool. Go to declaration. Yeah, so that's an int, right? So really, pulse event takes a handle and returns sign 32. And it's foreign. Create event A has some stuff, returns a handle, and it's foreign. And we delete all this horrible stuff. We delete all this stuff. And we say, you know what? That's a void star. We don't care. And these are signed 32s. All right. Okay. This is the messy sausage factory of getting Win API calls to work. My call to create event is really create event A, and these falses are zeros. Let's see if that comes closer to compiling. The declaration of wait timeout. I had already done it. Oh, and you know what? We don't do else. Let's just put all these into line. Right. Hey. Well, let's make sure it still runs, although we shouldn't be calling the condition variable yet, so it should just run the same as before. Okay, so now I'm going to do something that'll start breaking things. I'm going to go into here, and remember we had this variable do not queue, right? And where do we want to do this? I think we should set this in the outer mixer, because we have this threaded variable that we turn on and off, and we want to switch that value. So when we create the odd decoder, we will say if it's threaded, if we want to be threaded, decoder.do-not-queue is false, else decoder.do-not-queue is true. Right? Because queuing is what you do when you're threaded. Maybe I should make that not be called do not queue. Maybe I should make it do queue, which will be easier to think about. But whatever, it's not totally crazy to do it this way. So now I think threaded is still false, right? Oh, I set that in the other file. Oh, it's in. Yeah, this really should be in this file. This is a configuration. So this is not incomplete anymore. Now, if I run again, it should still work and just run fine. But then as soon as I switch this to true, I expect it to stop working. All right, who knows? Maybe everything has magically been done correctly and it will work, but chances of that, I don't know what they are. Apparently not high. Apparently not high. But we hit a failed assertion, and so it's possibly just a regular assertion. Like maybe I just left an assert false in there like before. I've been known to do that this stream. Mark relevant pages. Cache decoder line 153. Assert false. Okay, well, that's fine. I'm kind of regretting going through and adding all those assert falses the other day. They don't seem to have done me any help. All right, well, we got another crash. Probably just another frickin' assert false. Oh no, this is going to be like an index out of range. All right, so in mixer line 1656, we how can I must have broken the actual function. Because if this, oh, I'm not, okay, wait. Remove by index. That looks right to me. Let's make sure it's correct. You never know. Again, there could be compiler bugs or whatever. Could be me being stupid bugs. Let's make sure the compiler's recompiled. All right. So, whoa! How did we go from 3 to -1? Are we somehow... What? Is the for loop somehow including that statement? That's not right. That would be crazy. No, good. So what? We're going from 3 to -1 just by calling this function. How does that make any sense? I suspect I have a bug. I have a bug in minus equals now for structs. Like what? Zero. Did I totally break polymorphism this badly? I can't have because everything else works. Okay. Somehow array.count is being modified. What? Welcome to developing a programming language while trying to program in it. Okay, one of those lines is, let's try, I don't think it's the assert. Let's try that. Though. Nope, it wasn't the assert. we must be overwriting. Okay, it's either some bug with this being changed, which I don't think it is. I don't think this will fix it. So like I'm overwriting array memory somehow. Oh God. This is the, okay. We have pointer math in this language, and the thing is, see, array is a pointer, and we're assigning a pointer. We really need to do this. See, this is one thing, is it's easy to lull yourself into forgetting that because dot dereferences pointers as well. I don't know. I need to think about what to do about this because I feel like this will be a common mistake. So this again, this is just like star in C++. I'm dereferencing the pointer. Just so I don't have to do this ugly thing down here, I'm just going to do this. It's the same either way. That is going to be a common mistake, and I'm not sure what to do about it. Oh my God! Okay, I have to play a full round to celebrate, because it's crazy that this works. Oh, no! I'm going to have to play another full round. Yeah, look, it's removing stuff from the decode queue. So all that locking and condition variable stuff is all working. There's like, I mean, maybe there's a thread safety bug somewhere, but we're not hitting it. So we now have fully asynchronous compressed OGG file decoding. And I still have time and energy to keep going tonight, so we'll probably do ADPCM as well. First, I got to play a round of this game and delete this other, delete these. So we stop spamming our output. All right, I'm going to beat my high score. Oh, that did not, okay, wait, that didn't count. That didn't count. Oh, he dodged. Come on, come on. Need another spread shot. Or a shield, or both. Ah! Grim! Oh, that was grim. I didn't see my score, but I'm sure it was nowhere near 100. Oh, I can watch on the stream, 54. Because after I get 3 bullets, another bullet box will revert me to 1 bullet. So they become, they start out as things you want, but then they become things that are bad to pick up if you have enough of them. Okay. I'm going to heat up another tea. We'll take a few minute break. I'll come back and do questions. And then we will do add PCM compression, which should be a piece of cake now, because that's not even threaded, man. That just straight up just happens. Why do people keep talking about halide? Someone emailed me about halide, and I looked at it, and I didn't totally get it. I mean, it's fine. There are lots of domain-specific languages, and it looked fine for a domain-specific language, but there's a cost to using those, and usually the cost is not worth it. Now, in this particular case, if you do a great deal of that specific kind of work, maybe it is. So I don't know. I don't want to prejudge it. It's just to say I'm not totally sure that that's the thing. I'm eating these Rain Coast crisps. Okay, back in a couple of minutes. Okay. Someone was saying, is there going to be SIMD and all that? Yes. Question time, by the way, if anything that I was doing was confusing or anything. Yes, there'll be SIMD support. Yes, there'll be all that good stuff. This is a high performance programming language, and those things are important for the kinds of application space that I'll be in. However, my idea of how to do that stuff is just much like the way it's done in other programming languages right now. So I'm not implementing that feature right away, that kind of feature right away, because it's just straightforward. So I'm doing things that are going to be very different from the way other languages do things first, and features that are bigger and that shape the language the most. And then we'll get to stuff like SIMD eventually. How do I feel about making the derefs preference higher than dot? I actually don't know what the precedence is right now. So I guess it's lower. Yeah. That might be the thing to do, right? Because then it would make it easier to do that fix that I did to that one thing. But basically, I want to think about that problem for a little bit, that easy to make mistake, and see if I can just come up with some idea about it. You know, one way to fix it is just say, look, there's no subscript operator on pointers. If you want to do pointer math, you do the math, right, straight up. And that way that mistake would not happen. Another way to fix it would just be like, okay, look, you can do subscript on most pointers, but not on pointers to arrays, because that is likely a bug. I don't know. Something like that would mostly fix the problem. I wrote the parser by hand. Parsing tools are kind of terrible. They just make your life bad. And they solve the easy problem and not the hard problem of building a language. So I don't like them. They are useful for finding ambiguities in your grammar and things like that. But you can mostly do that by hand anyway. And I don't actually even care about ambiguities yet. I'll care about ambiguities eventually when the grammar is finalized. And in the meantime, it is much better for me just to have something that is very malleable, which ostensibly parser tools are trying to be malleable, but they never are. They're always terrible. If it's a smart kid, kids could use this language, but my target audience is people who are good at programming. There is a plan regarding use of this language for future games. However, I will not spoil what it is. The reason it worked is because array subscripts work on any kind of pointer, just like they do in C++, right? So I believe you could just make that same mistake in C++, actually. I think. Yeah, and the thing is, you often might catch it if the types on both sides of the equal are different types, but here they were the same type because we were moving elements from the array to itself, so type checking did not save us there. Yeah, in fact, I think I gave out source code to the Invaders game already last time I did a demo. I don't know. Next time I do a demo, before the demo, I'll put up for download like all the source code to everything. A lot of it won't be relevant, but some of it will. All of it will be running in the next demo, actually, so it's all relevant. So you'll be able to see any of this stuff, like any of the stuff I'm doing with this mixer, you'll be able to just see the full source code and all that. Inline assembly, I don't know exactly. It's probably important. No, the problem was the subscript, not the count. Like the reason that the count changed is because we overwrote the array itself, which has a count and a data pointer, with a garbage pointer from later in memory. That's why the count changed. All right. So let's go find some ADPCM. First, let's go into the mixer and find some more assert falses, because there may be some. We'll keep that one. So we're going to create add PCM decoder. Do all this stuff. And add PCM, in general, we don't ever multi-thread it because it's fast enough that you can just decompress it right away. And if you multi-thread, you lose the ability to synchronize your sounds. Like a lot of the time, you might want to start two sounds exactly on the same sample and have them be synced, right? That's a common thing to do in gameplay code. And right now, if you start two sounds on the same frame, that always happens. So you don't even have to worry about that. It's very good default behavior. But you know, if suddenly they're asynchronous, to keep the mixer simple, we say all bets are off. But you can convert a wave to add PCM, and because it's not asynchronous, you don't lose that ability. I don't know. It's so different today to learn how to program than it was when I started that I have no recommendations. Maybe play Infinifactory. If you get good at Infinifactory, you can program. I think the next demo will be well before January 26th, but it won't be for at least a couple weeks from now. I don't know exactly when it'll be. I have to get a bunch of work done. And I'm not releasing the code to the compiler yet, not for a long time. I'm just releasing the code in the language before the next demo. I use ADPCM because it's fast to decompress, right? So you have different things. So OGG, you get a good compression ratio, but it's slow to decompress, right? At PCM, you get a worse compression ratio, but it's very fast to decompress. So you can play a whole lot of add PCM sounds at once and not strain your CPU. If you start playing a lot of OGG sounds, then you start spending a lot of CPU decompressing OGGs, and that makes you sad, especially if you're on iOS or something. I'm using the keyboard that Casey got. He said he liked it, and I don't know, I feel it's about like the same good as my previous keyboard. I'm indifferent to it so far, but I'm going to keep using it for a bit, and we'll see how it goes. Don't ask me about the specific. You can look up the specifics of add PCM compression yourself. It's not worth me spending time on the stream. It's a compressed format. There you go. It's somewhat lossy. It's fast to compress, fast to decompress. Okay. Now I'm going to want an add PCM file, actually. So I'm not sure what that should be. Let's go back to the braid. Let's go to braid. And let's get one of these puzzle piece sounds, maybe. Maybe these are funny. Where are the puzzle piece sounds? got piece. Let's do that one. So that's a pretty big sound, but not giant. And so, you know, we might just convert a whole bunch of sounds like that in our project to ADPCM. In fact, in the witness, almost every sound is either OGG or ADPCM because sounds, when you have a lot of them, they take up so much space. It's crazy. All right. So I'm going to break out the trusty gold wave, which, by the way, I have purchased a long time ago, but I keep downloading it onto other computers and don't deal with the BS of registering it every time. Like, I think they gave me a separate download or something and I lost it. I don't know. So I just use the evaluation edition without shame. All right, so Goldwave will let me save this as ADPCM. Let's keep it at 44 kilo. Oh. All right. So, you know, we got almost 8-to-1 compression off that. Right? So that's ADPCM and this is wave. Although something's messed up, actually. Oh, I saved it as ADPCM mono. That's stupid. I was like, it's suddenly a much less rich sound because I saved it as mono. So we're going to get a worse compression ratio, but okay, ADPCM, 44 kilohertz stereo. So it'll be 200K. Whoops, I oversaved the original file. It's fine though. So it's 200K, whereas the original was almost 800. So we got something like 4-to-1. And if we drop the sampling rate, we could do even better. All right, so that's what the ADPCM sounds like. So let's add that to Subversion. Now, when should I play that? I'll play it when you pick up too many bullets. Rename too many bullets.wave. All right. So in invaders, so what do I call it when you have shot type too many bullets? This is totally an excessive sound to play, but hey, what do you want? Okay. Now the first thing to do, actually, okay, wait, did I paste all that ADPCM code in? Do we have to make that compile? Oh, yeah. Let's do that. Because I realized also I'm going to have to modify the wave loading code because I believe the wave loading that I put in doesn't recognize ADPCM yet, although maybe it does. I don't know. Okay, so we're going to our C++ version of the code. I was a little bit inconsistent with my naming. So we're going to paste a bunch of C++, as is our general modus operandi. All right. So again, we don't have includes. We don't have forward declarations. I originally got this code from the SDL. Let me actually find that. Giving credit where credit is due. The SDL guys are cool about letting you use their thing. All right. So I'm going to replace arrow with dot. We always do that. Oh, we're getting rid of the page, right? So I'm going to replace ADPCM page with cache decoder page, because that was a simplification that we decided to go in for. It's not GPL code, I don't think. Is it? No, this is not GPL. This is not the GPL. This is a very permissive license. Whoever said GPL does not know their licenses. Okay. I just like how much smaller and cleaner things get when I put them in this language. That's all I'm saying. That's all I am saying. Okay. I just realized I'm ducking out of the frame most of the time. Sorry. Sorry. Okay. So let's see what we did when we said create og decoder. Yeah, we just inlined all that stuff. So let's do that here too. Start compressed file. Comes on back up. I should call this cached ADPCM decoder or something, but I'm a little bit inconsistent on the names because I might want to just name them OG decoder or whatever, right? So whenever I'm indecisive, I just let the names be inconsistent. Someday I really should make a script that does this. We don't need that cast anymore. But we'll leave that in case we want to fill our buffer with random noise. That's a function prototype. We don't need that. Don't need that type declaration. I'm going to do this just to make it very clear, because that matters. Very straightforward conversion. Is page.data, it's a void star. Yeah. I think I automatically coerce void stars, so I think that should be fine. Okay. Oh boy, okay, so I don't support array literals right now. So that's going to be entertaining. Here's what we're going to do here. This is disgusting. Step table. And then we're going to say init step table. And this is where it gets gross. I'm going to say index is 0. And then I'm going to say replace comma with step table sub index equals index plus equals 1, semicolon, step table sub index equals. Okay, let's see what happens here. Oh yeah. Now you're cooking with gas. Now you got a stew going. So that's how you deal with not having array literals, folks. Oh yeah. And then, here's the trick though. This won't cost us anything at runtime, because at compile time, we will say run init step table. Think. I think I took out the thing that, yeah, I think this will work. When we get array literals, let's recopy the step table from ADPCM decoder.cpp in the witness rather than reconstructing this horrible thing. All right. So that is what it is. What do I do in the compiler? I want to double check this. Yeah, okay. Just checking. So we're going to have to do that with this other table too. That'll be easier. Index table is an array of 16 S32s. Oh, I should assert index is equal to step table.count minus 1. In case I get that wrong. Index table, we're going to do the same thing. I'm going to replace step with index. Actually, let's, instead of index, let's make it I. Right, that'll be easier to read. Fun for the whole family. And then step table becomes index table. I 0 index table I equals -1, blah blah blah. Blah blah blah. Blah blah blah. Blah blah blah. Asserting that I is equal to index table count -1. Run init index table. I could convert braid to this language, but it would be a little bit painful still, mostly due to lack of array literals like I'm working around here. But I could. There's still some things I want to do before I start doing that kind of thing, though. Okay. I might have to explicitly cast these. We obviously don't care about GCC warnings. Well, this is going to be a pretty good test of all the bitwise operators and things. Hopefully I didn't screw those up when I programmed them. Why is nibble signed? What happens if I... Wait, nibble is U8 here. Such a pain in the ass. All right, well, why'd they make it signed and then unsigned? Ah, see, this is why it's good to be strict about your stuff. Because that was an inconsistency in types in the ADPCM code that is not necessary. All right, we don't have plus plus. I think I did right shift equal. I might not have done this operator. Let's find out. Math.h. Oh, I totally skipped this sine wave stuff. Oops. Oh man, did I implement fmod? I think I did. I think I've got fmod and sine. I don't know if I have mpi. don't think I do. That'll come back to bite us later. Although, you know, this is all for this sine wave stuff, so let's, we don't need that right now. $803. Yeah. 805. Oh, for loop. For I goes 0 to 3. Really? I bet it's this, right? Yeah. New sample equals new sample, right shift 8. The joys of an incomplete programming language. All right, so we're back down to the next C++ code. That's pretty good. You know what? No, I was going to do another regex replace, but it's not worth it. I'll just do this by hand. It's probably a little tedious to make me watch me do this, but whatever. Why is my Emacs not liking this? Come on, Emacs. Ah. Okay, whatever. So really, this should be a string. We'll see. He's using the whole star encoded plus plus thing. I don't tend to like that. So we may not ever support that. Right. So, getting down to the meat of things. Well, probably going to get lots of these. Left type void. That is a compiler bug. Left type void. Okay. It's fine if they're using the 16 everywhere, I can do the same thing. Okay, compiler bug thinks static array dot count is of type void ADPCM. So I'm just going to work around that again. 89. Since they're using these hard-coded numbers all over the place because those are hard-coded in the specification, I am fine with doing it here. 786. I need an explicit cast. It's a little bit scary, but so we don't want U8, we want S8. Why are these S32s? I don't know. Let me just, yeah, the index is S8. All right, 806. All right, that definitely can just live on the base class. That's a bug in the witness also, probably. Oh no, because I probably, let me check that in the witness. In the witness, so we have num channels here, and then yeah, we don't have num channels. We moved it down to the base class for this, so it's not a bug in the witness. It was that I forgot we were doing that. Okay. So, right, 806 U8 versus, I should make a little thing sometime soon. I'm going to make an option that runs Emacs client and just pops Emacs to the right place. But that won't happen yet. All right. Left type is U8, right type is S32. feel like I'm going to mess something up here. That'll be fun to debug. Redeclaration base. Oh, your base. Oh, because I'm using, and we can't shadow that. Yes. I could have also not called the other thing base. Incompatible structs, 1089. Wait, in mixer. That's a little inconsistent because before we just returned the base class. I don't know. Ay, ay, ay. Yeah. Left type S8, right type U8. All these implicit conversions that were floating around in the old code. I'm not sure about the precedence here, so I'm just gonna 902. Fiber 7. (509), we deleted all the extra trailing samples the other day. That was a complication that we no longer want in our mixer. We do the same thing, yes. Whoops, that should be a pointer. Incompatible structs, 513. Oh, you know, yeah. Let's do that. Length in bytes, not a field of sound data. It's buffer.count now. Still got to get rid of extra trailing samples. Yeah, we kill trailing bytes. Why is decoder? I keep forgetting to make it a pointer. When I pasted that, I must have just forgot. So much extra trailing samples. Wow, you know, this makes me worried because I thought I'd gotten rid of that as a concept in the mixer, but I wrote the ADPCM code very recently, like a month or two ago. And I seem to have sure put a lot of work into. I remember agonizing over the extra trailing samples, so that's maybe not so good. Type. Right. Okay, that's why. That is why we did this. All right. Well, who knows what the hell that is going to do. It's probably going to do something scary. Like, actually, it's probably going to play garbage because I think our wave loader doesn't tag things as ADPCM. So it's just going to think that those are wave samples or something. It's going to be horrible. Wait. Oh, yeah. I need to get too many bullets. Yep. So that horrible noise was us playing compressed ADPCM sound as wave. So in order to know whether all that code I transliterated worked or is going to die horribly, I have to at least get there. So we go back to invaders. When we load our wave file, we need to know if it's ADPCM and do some things accordingly. I'm just gonna look at the witness again, so I'm gonna avoid spoilers here. What am I looking for? What did I call the type here? Decoder ADPCM. So that happens in the mixer. Okay. Let me try and close some witness stuff. All right, so I'll turn the desktop on. Even though we're looking at witness source code, scary. So I have this function, and in fact, there's a version of this in the wave file module that reads the header data. And it returns a wave format X. But I feel like this was an extra wrapper more than we want. So my wave load file is this. It would read the riff and wave chunks. Yeah, I guess I factored a lot of this together when I did this version over here. Oh no, this is basically this. Q chunk, fact chunk. I think what I did, I might have pulled this out of braid or something, because the fact chunk is something that ADPCM uses. Hmm. And I did this thing where I shoved an extra item onto waveformat X, which I'm not sure if that's a good idea. And I'm starting to get tired, so I didn't sleep that much last night. So do I try and do this tonight, or do we call it here? Let's at least... Okay. Read U4. I don't have read U4B. What? What did I do in Witness? Wow, okay. I'll just copy that. Why not? Paste from read chunk size. So, you know, we're doing that. Doing all that good stuff. So, okay, I guess I just, I changed the tenor of this code to be non-destructive and stuff. So, we print that out, and then what do we do about our waveformat X? The thing is, if I change my waveformat X, I'm going to screw with some other things that use it. So I don't want to do that. I'm going to return this as an additional return value. All right. So now the reason that's in there, so an ADPCM file is block compressed. So it essentially rounds to the nearest like 16 samples or whatever. So if you want to loop a sound, you need to know exactly how many samples it is. And you know what? I just realized, I think I live streamed when I wrote this code for the witness. In fact, I remember that, yeah. Anyway. You need to know how many samples the sound really is, and that's what the fact chunk tells you. All right. I shouldn't call that fact chunk samples. Sample count. Sample count. Alrighty, so we're doing all that. It's good times. So we get the wave header, and then in the witness, okay, we check the format tag coming back. Let's just do that in invaders every time to make sure that's working. So here, this format is a wave format X. And I could say print some name format tag is something. And name, or base name, and format.w format tag. Right, all right, 179 over here. I messed something up. Now this. Return format, comma, samples, comma, false. Oh, it's a different sample. Grrr. Sample count. I shadowed my variable. Okay, so let's see what our format tags are. Oh, you know what? I need to play the sound. I need to get too many bullets to actually see the format tag, because we're not preloading our sound effects right now. We're only loading them when we play them, which is kind of ghetto. Yeah. All right. Too many bullets. Format tag is 17. So that's correct. We're getting that value back correctly. Now I need to define that probably. Right, so we need to look up, yep, it's 17. Let's see if we already have that. Nope. So let's declare those. All right. Now, once we get our thing, we say if format.w format tag is equal to wave format PCM, else DVI add PCM, else assert false, you're loading a garbage wave file, buddy. We should probably do something nicer than assert, but whatever. Okay, this is linear sample array. This is add PCM compressed. Is that what we called it? I don't know. We'll find out if we get a compile error. Redeclaration of waveform at PCM. Declared it in the mixer. All right, well. Well, that add PCM is wrong, probably, but I didn't use it. Whatever. Okay. Add PCM compressed. Forget where I define things. It's just add PCM. All right. It's just add PCM. It's a little bit inconsistent. Let's make it more consistent. Whoops, I gotta take out my printfs in array removal. Oh, I didn't get the bullet. I'm so tired, I'm missing all the aliens. Okay, wait. I gotta remove this thing. Because we solved that problem long ago. I don't want the shield because that'll prevent me from picking up too many bullets. Oh yeah, the good stuff. Ooh. Alright, but that's good news. It may not seem like good news, but it is because it means that we hit some of the new code somewhere. Right? If we were just playing the old code, we would have kept going and played a garbled sound. I probably didn't initialize some field that I need to initialize. So that I don't have to play every time to get this crash. Now I'm just going to play that sound at startup, right? Right here where I place commando, I'm also going to play too many bullets. So that should crash us right away. And I'm going to run us in dev env. I'm going to close the witness here because I don't have too many frickin' things. Dev env. Dev env. Total crash. All right. Cache decoder, line 487. Well, I guess data is null to begin with. Okay, that's pretty weird. Right? Let's go. Print R3 dot pointer. Oh, it doesn't. Come on, guys. It knows where the source is. Oh, I'm saying print. Why am I saying print? So R3, yeah, R3 is null. And we're dereferencing null. Right? So that's no surprise. And R3 is probably the parameter. Right? We can look up at the top. Yep. R3. This is the context parameter, and this is the return value. So Y why are we calling this with null sound data? Because I pasted the code, or I uncommented after we did. Remember when I did this change where I moved this up and stream.sound data isn't set yet? Well, I hadn't done the right thing. Blah, blah, blah. All right. I'm just going to try and run it. Seems like we're crashing again, but I bet it's somewhere different. Assertion failed. Okay, that's good. Sort of. Whoops, I ran another dev end. Whatever. We got dev ends all over town. Okay, so create an ADPCM decoder, line 489. It's basically the same place, but now we hit the assert. W samples per block. So we're not initializing that stuff. We're supposed to copy that from the wave format. Is what we're supposed to do. Don't we know anything? So in our loading code, equals where are all these freaking windows I have up? What is even going on? I don't know. Right. How did I add that in the witness? I reopen the witness. No, talking out my work like this does not help for coding. It makes me very slow and feel dumb. I get stuff done way faster if I can just crank without getting verbal. All right. But it's still interesting to stream sometimes. It's a little bit fun, and you know, it's a different way to program. So what was I even talking about? Oh yeah, W samples per block. What did we do about this? We also put that on the wave format X. Well, let me see what happens. It's actually probably fine to make wave format X bigger. Let me see exactly how I did it, because I do believe that let's just try it. Okay, so let's just try this. Actually, yeah. So I want to see if direct sound still inits correctly with all that, because you have to pass it wave format X's to do stuff. There will be more demos. The language is not feature complete, not even close. What? I'm in the wrong editor. So I'm going to comment out the too many bullets for a second, so we don't crash right away. And I want it see if things initialize correctly. No, not Devin. No. No. Too many Devins. It really didn't initialize correctly. All right. Well, let me see why. If it's an assorted mine, it is. Now, okay, so the mixer is not initializing. So Windows is grumpy at me for adding something to wave format X. So what I'm going to do is I'm going to make something. This was a bad idea. I'm going to make something called wave extra info, right? Samples according to fact chunk. I don't like this kind of naming convention, but whatever, I'm going to be consistent. So we're just going to return a wave extra info. Extra is wave extra info. All right, so an annoyance in the language right now is I don't have literals for structs, so I can't give this a default value. And there's no way to say optional argument where the default value is the default value of the type. Maybe there should be syntax for that. So now I have to return 4 things all the time, which sucks, but whatever. I'll clean that up some other time. See, things like this motivate me to add features to the language, so that's good. No, not Devin. No. Got too many commands in my buffer. All right, return statement is missing, line 134. I missed a few. 182, God, all right. Yep, one little lack of a tiny feature makes things a lot more inconvenient. So extra dot w samples according to fact chunk is that. Now, where does w samples per block come from? I need to set that also. Extra to extra. So Where did I get that in witness? Format tag, channels. All right, so parse waveformat X. So let's look at the witness again. So the format tag. Do this at the end here. Looks really pretty different. Oh yeah, instead of reading the things out, I do endian swaps. That's gonna be. I decided to do it this way because it's faster. Okay, that's annoying. Well, I'm gonna have to do this slightly differently. This is test code here. I don't even know what that's doing there. I was testing my swap too. All right, so if all right, so all right. No, I haven't made a go-to. All right. So I don't think I have a read U2B yet. All right. So I'll do that. That returns an S16. If we have less than 2 bytes, we read an S16. We swap to it. I do have a swap to. All right. So now, though, I'm going to say cursor is data, cursor dot data, I think it's called data, plus equals. Let's try that. Just forgot to change that. Line 127, this is W format tag. Read YouTube, cursor. And then too many arguments. Wanted one, got two. Oh yeah, because we don't do that in this language. We don't do that either. Okay, right, so I need to put back in my playing that sound at the beginning, and then we should hopefully see the format tag. Crash. See what happened though. I don't think that samples per block is correct. That doesn't make any sense. Let me print out the end block align as well. So there's no way we have 2K blocks with only 2 samples in them. So I messed up my read. I also messed this up. Okay, wait. CB size 2, 4, 8, 12, and 16. CB size. I am confused. How are we getting it to? Let me just print this stuff out. Print bytes. Data, comma, 18, right? So space, comma, data sub it, format int, base equals 16. Let's see. So I didn't mess that up. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Indeed, it says 2, but then there's an F9 because I went too far. Let's go to 20. I bet I'm just skipping over. There's some other 2-byte value there. So F9 Google has a calculator, right? So 16 times 15. Down here, 16 times 15, right? Plus 9. That's F9. Plus 7. No, F9 times 256. Wait. No. F9. Okay, 7 times 256 plus 249. 2041. That is a correct looking blocks per sample number. So I don't know why that I have to do that, but I'm just tired, man. I'm just doing it. Okay, so that is a sensible number because there's a little bit of header in every block and all that. So we're passing the W samples per block out correctly now. That's all good. So then what's the problem? Problem is, of course, I've forgotten something else, probably. So let's see. Let us see. Why do I even have that? Make page ADPCM. It's not in the same place. Good. So I think decoder.sound data is still null, right? Pretty sure that's all that's happening. I gotta stop my debugger. Because we're on Windows. Frickin' Windows. You can't overwrite a file if it's open. Yeah, so what d.sound data equals data, people. It's the first thing I did before. Also page size and sample. Why am I doing these things in different orders? All right. Okay. So we're probably crashing somewhere else, but I realized that I'm not now using I need to set this based on that fact chunk data, right? Extra. And channels equals right, and all right. Whoa! I didn't have the headphones on. I don't think it played the sound though. Right? It's a long sound. I would have heard it. Nope. I gotta get too many bullets. Oh, come on. Yeah. So, we're just not hearing the sound at all, which is not the worst outcome. Not the worst outcome. Let's just see if it's playing every frame like we did with this first time. I think not. We've only got commando. I didn't comment that out, did I? I'm still playing too many bullets. Yeah. Okay, so last time we had failed to set the repeat start and end position, but here that looks fine. Well, I need to start doing the same prints that I did before. Good old printf debugging. Too many bullets, but we never create stream. Oh, create stream new wave. We never create stream too many bullets, or we never get success on it. And let me go back over here and comment out this spam. Too many bullets. We never even try to create a stream for it. Why? Wait, we get new wave, too many bullets. Oh, maybe I'm missing it. New wave, commando. I don't see it, too many bullets here, people. Okay, that's garbage. That, we're setting the number of samples to 0. I didn't even read that printout. I hope somebody on the stream caught it. People. What do I do about that? I'm going to ignore it. You know what? We'll deal with the fact chunk later. I seem to recall that it was unreliable, which is annoying. For the witness, we add PCM, compress things ourselves now, and fill out the fact chunk ourselves. But if you use an external tool, you could be very sad. Did we even parse a fact chunk? I don't think so. Let me pull too many bullets into Emacs. I don't see a fact chunk. Oh wait, there it is. There is a fact chunk. But I exit when I get data. When fact is after data there. That's what's going on. I'll see if any of our sounds load after I take this out. Right, the fact chunk is after the data chunk, so we can't early out. All right. Okay, so now we got a bunch of samples. I don't know if that's right, but it's plausible. It's about right. So let's see where we crash now. Integer division by 0. All right, now we're playing with power. 594. Well, we're not copying n block align. See, I'm forgetting to do all these things. All right, so add PCM data.n block align, n block align. Let me just look and see what else is in sound data. Just those two. Of course, I didn't. If I'd looked before, I would have known, and we would have saved that crash, but it was only a minute or two. Ain't no thing. Wait, I don't think it played it. But we didn't crash. Try create stream too many bullets. Success create stream too many bullets. All right. Well, let's comment those out then. So we've gotten further. And let's go back over here and get this one. Get this one. Well, it really thinks it's playing that sound. It's interesting. Maybe our ADPCM decoder is just hosed. That would be harder to debug, like if it's just filling our pages with 0 or something. Let's try that. All right, I'm going to take a short break. One last little pick me up. And then I'll come back and we will debug the very last of this. I want to get it working tonight. Get it working. It's so close. Any questions on what the hell is going on? Does this make sense to people? Are we in a reasonable spot? Is there a Lua troll in the channel? Oh my god. Lua. I'm not going to get into a language flame war. Lua was fine for a long time ago when you just maybe wanted a little scripting language to do simple things, but I'll just stop there. I mean, my opinion on it is my opinion about most things, right? You don't really want to program in a slower language like that unless it buys you big expressivity, which back a while ago, people still sort of thought that that kind of language was more expressive and that you got things done faster. But I think now that is mostly proven to be not true. So in fact, what happens with a mushier language like that is that as your code gets bigger and bigger, you have more and more problems. So I don't encourage people to uptake that type of language design. Full and an equal are two different tokens. I'm not in the mood to do autobiographical questions right now. Coroutines, I don't know. Maybe. If there's a way to do them that adds a lot of value compared to just doing them yourself. Okay, what was I even doing? I was going to debug something, I know that. Oh, yeah. I was going to do a verification like we did yesterday that this sound is even playing. I guess there's not really any zero volume. A little bit. All right, so, well, let's just write our simple code and we'll see what happens. So, too many bullets. Decoder, just like yesterday, we're going to create ADPCM decoder. For sound.sound data. Bullets, too many. Is that too many.sound data? So we've got a decoder, and then we're gonna mark relevant pages. N0, 5001, let's see, 12,000, 18,000, coder N0, N1, containing, right? So now we're going to say page is find page containing cursor, decoder, N0 plus 5,000. And we're going to print page is something. Let's just try that. Right, so we're manually getting a page out of the decoder. Whoops. I really should figure out why that implicit cast doesn't happen anymore. Okay, anyway, let me comment out that other thing because we know this is happening. So page is true, wait. Find page containing cursor. All right, so found start end data. Found start end data. All right. Oh, Casey's here. Hello, Casey. When I say doing coroutines myself, I'm sort of just saying that like actual asynchronous code is the important part. Like doing a good job on multi-threading in a performant way that also like helps you not make thread bugs is important, right? Any other stuff is small potatoes as far as I'm concerned. So like syntax to make it easier to declare a coroutine that's not even asynchronous. Like I don't know why I would focus on that in a language design. But maybe I'm wrong. Maybe maybe that's important. It just doesn't seem that important to me right now. Dude, so Krasinski, have you even been watching this stream? Like I run Visual Studio and I try to press the start button even just to run my one executable and it like lags for 5 seconds before doing it. Like everything is like that. It's unacceptable. It's all this software is obviously unacceptable. And people are, I don't even know what people's problem is that they even can look at that and say, no, it's totally fine. Like, why is there even a question about whether that's good software or not? What? Oh my God. Yeah. Anyway, I'm not going to argue about that. I'm going to debug this. What was I eating? I'm so tired. I don't even remember what I was doing. Oh yeah, we were finding the page containing the cursor. I need to. Okay, so we did load the page. We found it. We got some data, and I guess I didn't save my shorts, but whatever. So I'm going to say shorts is cast pointer to S16 data for 0 to 20 print, comma, shorts its print. I'm going to make this easier to find because I keep squinting at the thing. Put it in between giant stuff. Okay, what it looks like to me, wow. So this is disturbing. It looks like I messed up translating the ADPCM code because we've got values, but they're all single byte positive values when these should be 2 byte values. Let's go to 2000. Yeah, look at that. That is hosed. And wow, that's so hosed. I don't even know what to do. You know what I'm going to do though? Yeah, why didn't I even notice that it's like the same 2 numbers? Okay, obviously what this means is the step table is messed up or something. My stupid thing that I did to get around not having array literals might not have worked for some reason. So let me do this. For 0 to 89, print step table sub whatever equals whatever, comma it, comma step table it, 0 to 88. Let's get rid of this 2000 now. That's overkill. It's absurd overkill. Dude, code is bad right now by every metric. It's less functional than ever. It's harder to understand than ever. It's harder to maintain than ever. It's slower than ever. It wastes more energy than ever, thereby destroying the environment more than ever in the past. Like, what metric is code good by now? None, really. I mean, except in limited domains. So like in video games, for example, we're managing to build things that are a lot more complicated than we ever have in the past. Although we're kind of plateauing lately, I think. But, you know, over the past several decades, we've been building things increasing in complexity, in inherent complexity of the actual task we're accomplishing. That's not true, for example, in the web world, right? Most web software is not interesting at all. It is increasing in complexity, but it's all needless complexity, as nearly as anyone I know can tell, right? Mostly because those languages and environments are so screwed, and mostly because, and partially because you just throw a zillion young, eager engineers, none of whom really know how to program, at bad programming languages, and you're just going to get a giant mess. Nearly as I can tell, that's just what happens is, you know, .com companies can survive their giant mess for a long time just because they have so much money, right? There's this power law determining how much money you make off your shitty website initially, and if that's enough, then it doesn't matter how bad your software is because you can just survive it due to having a lot of money. It's a bad situation, man. I don't even know what else. I've ranted about this many times. Casey has ranted. Hey, look, the step table doesn't work. Okay, that's good. I mean, it's not good, but it's good. Well, why don't I just do these at runtime? do these at compile time and figure out why my compile time init did not work. It's probably for an obvious reason. Oh, yeah, I think I know why. Anyway, init index table, init step table, tables initted false, if bang tables initted. All right, that's stupid. We shouldn't have to do that. If I had array literals in my language, we wouldn't do that. I mean, you might think that economic pressure makes good code seem extravagant, but bad code costs you more in the long run than it does to make it into good code, right? Both internally, so for your own team, if that has any kind of a life, and externally. Like, bad code is a massive, massive negative externality, right? People should be taxed on that externality, in my opinion. Whoa, did it? Okay, well, something happened. We've got more reasonable numbers. I want to hear if that sound played. Whoops, why did I recompile? Okay, it sort of played. It was sort of messed up, but you could hear it there. So I'm going to run this under Visual Studio and figure out why it asserted. That may give us a clue. Look at that! I hit that start button. It took several seconds to start. All right, so we've got a null pointer dereference in recompute page. Really? That's weird. I guess we're going beyond the edge of the sound, probably, which we're not supposed to do. I don't know, line 150. Well, recompute page. So we're dying on actually line 608, which is the decode, but we're dying on this line. That's weird. Oh no, we're dying on line 606. Sorry, frickin' Visual Studio puts the cursor in the wrong place. This is the assert. So source bytes to read. We're reading a non-aligned amount of bytes because it's the end of the file, probably. I'm just going to comment out that assert for now. All right, so now, in theory, we won't assert anymore. I'm going to turn off the command. As awesome as the commando song is, I'm going to turn it off temporarily so I can hear what is going on with that other sound. So there's obviously a problem. That ADPCM sound is clipping. It's clipping a lot. So I'm not sure why. I may not debug that tonight because it's late. I mean, there's sort of two ways to debug that. It's like I can A/B that versus the output of my C++ version. Or I can just look at the code really carefully. And I guess I can A/B it via a very controlled test like this one. So I'm going to leave this test commented in for now. Okay, but this is mostly success because we're playing the sound. So just to recap today, right? So we've got OGS playing asynchronously, like fully threaded, and that's working very well. And we've got ADPCM sort of playing, but it clips. So like I messed up some casting or some math or something. And that's not perfect, but it won't take much longer to debug, I don't think. And then we'll have a fully functional mixer that is more capable than most mixers in most game engines, which is pretty sweet. Anyway, I think this may be. Do we have any final questions about, like, on topic about the code that happened tonight, or about programming language issues that were brought up directly by the stuff we worked on tonight? So Dr. Jeets is talking about coroutines as multi-threaded state for some game object. Okay, the problem with that, or multi-step, did I say multi-threaded? Multi-step state. I mean, that's fine, but it's sort of more of a scripting thing. And the problem that happens is you have all this implicit global state due to all your different coroutines blocking on certain things. And unless it's a very tightly controlled situation, it's very easy to have a rat's nest of invisible dependencies and bugs. You basically have the equivalent of threading bugs, except they're like, I didn't realize I was yielding on this thing bugs, right? So unless you build an entire language around coroutines, or build some kind of a way to, I don't know. I just don't think it's the best way to do things. I mean, I've never seen a system like that that solved more problems than it created. But maybe there's a right way to do it. I don't know. Someone's asking, how much easier is this for making an audio mixer compared to C++? It's about the same in terms of that. Okay, where this language is going to win is in other issues around building large programs. Like I'm not trying to be vastly different than C in terms of what a function looks like at level of expression, right? Like your function looks like, hey, assigning variables and all that. So first of all, I do reduce the friction on all that stuff, right? But secondly, all the things around building your program are going to be much better. All the things around making sure or checking your program with common checks to find common problems is going to be way better. And metaprogramming is going to be vastly, vastly better. It's already better in many departments, metaprogramming, and the next demo is going to have something that just basically destroys every other language. So that'll be pretty good. So that's the thing is, you know, writing a small program or writing a small module is not that bad in any of these languages. The problem is just that as your program gets bigger, it becomes harder and harder to deal with almost everywhere, right? So what do you do to make sure that your program stays nimble as it gets big, but also you know, doesn't fall apart, like stays robust? And that's what I'm working on. Oh, also, you know, I lied, actually. It is easier to do something in here because there's no header files, right? No header files automatically means less typing. Having done the audio code, am I happy with how it went here? I am, actually, even though I have to do some stupid stuff like initializing those tables at runtime. We haven't really hit any major compiler bugs in pulling this over, and this is really non-trivial code. Like, it's multi-threaded, real-world audio mixer stuff. Let's even see. So that's 900 lines. That's 762. That's 1705. So we're up to like 3,400. It's 4,000 lines. This is including white space, right? But and then did I miss anything else? Anyway, it's about 4,000 lines of real-world, heavy-duty code that does a lot of work. More than that in C++, again, because of the header files and all that stuff. And so this is the first time I've ever tried to do anything like that, and I think it went very successfully. I would like to actually have a tool to sort of convert to this language from C++. Like, I don't think that tool can do everything, especially if you start doing crazy C++ template stuff, but simple variable declarations and things like that should be easy to convert syntactically. All that said, the syntax of this language may change anyway, so etc. I am not working on the LLVM backend right now because I tried playing with LLVM and I hated it. I just, don't like. LLVM is like against many things that I stand for. It's so demoralizing even to look at that code or to even try to compile it. Forget looking at the code. Just download it and try to compile it and then come back an hour later when your laptop battery's gone. It's ridiculous. It's absurd. Oh, let's see how big the compiler is, by the way. Let me see if there's any rogue CPP files. How about H files? Nope. So compiler is 21,000 lines. 21,065 with white space stripped. So that's pretty good. It's a lot smaller than LLVM, I'll tell you that. Of course, we don't do native code generation yet, but we will. All right, folks. I am gonna get out of here now. Maybe I'll stream sometime this week and finish up this debugging because it would be good. It clips a lot or something. There's noise in it, that's all I'm saying. All right, but that was a pretty reasonable session. 5 or 6 hours, six and a half hours of programming. Yeah, I drank a lot less caffeine today, so I should be able to sleep tonight. Thanks, everybody, for coming by. I need to figure out what the next user level, like this is, I sort of think of this mixer stuff as a user level task. And now that this is almost done, I need to maybe think of a new one, maybe 3D graphics or something. I don't know. Maybe I'll hook it up to the Vive SDK and you can see me stream waving around things. I don't know when the next demo is. It depends on me getting a bunch of work done. We'll see. Bye.